Jmath.
In this video, we're going to look at the counting principles, but if there are certain groups that need to be together or that need to not be together, you'll see at the end what I mean. Let's do this question, and then I'll explain as we go along. Otherwise, it's going to sound too complicated. 10 people line up for a race. There are 3 Americans, 4 Jamaicans, 2 Germans, and 1 Brit, okay, from the UK. In how many ways can they line up for a race? Now, many times with these questions, the first one will not specify if they must group together or whatever. So then you just see them as 10 different people. So the answer for question 1 would just be 10 factorial. Now, something very important. They do not need to tell you if something can be repeated or not repeated. These are people, so one person can't run in 10 lanes. Question 2, how many lineups are there if the Americans must run next to each other? So let me just explain a little bit here. So the Americans are going to form a group, okay? And in the group, there's 3 Americans, but I don't know how they're going to sit and in which order. So in the group, there are 3, but I don't know how they're going to line up. So for lane 1, there's 3 options. As soon as one person got its place, then there's 2 options for the second one and 1 option for the third one. So this is 3 factorial. But now they do not tell me anything about the other 7 that's going to be there. So remember, they are then just seen as 7 single people that can move around. So now the reason I say it like this is because the one probability is that the group is going to be first and the 7 people on the right. But remember, one person can go to the left of the group, or 2, or 3, or all 7 can be on the left. And it's just going to be impossible to think of how many there are. So that's why I'm teaching you this strategy. So the group can move around between all the other ones. Okay, so please follow this method and you won't ever get stuck with group questions. So how I'm going to do that is I'm going to check how many groups there are. In this question, there's only one group and it's the Americans. So I'm going to say that each group gets a factorial. Then I'm going to make a bracket and I'm going to write down how many singles. So it's not single people if they're married or not. It's how many are not in a group but can also move. So there's 7 people that can still move around. So I'm not giving them a factorial. I'm just saying 7. Plus, how many groups can also move around? So the Americans, like I just showed you, can also move around. So there's 7 people and the group that can move around, and that gives me an 8. But I'm writing it like this. So the answer to this question would be 3 factorial, 8 factorial. Okay, so in front of the bracket is each group that must be placed together, and then in the bracket is the amount of singles and the amount of groups that can move around, and I give that whole bracket a factorial. If I do it that way, I will never make a mistake. So now question 3, how many lineups are there if each nation runs as a group next to each other? So I still have the 3 Americans there, then the Jamaicans. Okay, so they were 4 times 3 times 2 times 1. Then there were 2 Germans, so 2 times 1. And then the guy from the UK runs as his whole nation, so he is only a 1. I can write 1 factorial, doesn't matter. Okay, but this is unfortunately not good enough. That would not give me the answer because the Germans can move in between, or the Germans can move in front, or the Jamaicans can move, or the Brit can move, and there's just too many variations. We're going to get so confused. So let's follow the method. So each group gets a factorial. Okay, 3 factorial, 4 factorial, 2 factorial. Just to not exclude Britain, let's just put them there. Now, how many singles are there? There aren't any singles there. And then plus, how many groups can move around? And then factorial. And if I write that as my answer, I will get full marks. So 3 factorial, 4 factorial, 2 factorial, 1 factorial times 4 factorial. Okay, so there was another variation. I don't want to confuse you guys, so you can skip if you don't want to hear this. But if I see the Brit as not being a nation, but a single, I can say it's 3 factorial, 4 factorial, 2 factorial, the 1 Brit plus the how many groups can move around. So now the Brit is not a group, and then that's how it changes. So it's actually still the same thing because 1 factorial is just 1. So I hope this makes sense, what you would do with groups. Let's look at another example as well. So the next question, 4 girls and 3 boys go to the movies. In how many ways can they sit in a row? Now, with the first question, they did not specify boys or girls, and I can just see them as 7 people. So the answer to this question would just be 7 factorial. Because remember, if they all stand in a queue next to the line where they need to sit, then one person will sit on the first seat, but there's 7 possible people that could have sat there. So 7, then 6 times 5 times 4 times 3 times 1, and that is just 7 factorial. Question 2, in how many ways can they sit if the boys and the girls sit as groups next to each other? So a group of boys, okay, and there were 3 boys, and then a group of girls, and there were 4 girls. They didn't tell me who sits first, so I must then multiply this by 2 to say, okay, but the boys could sit first or the girls sit first. But let's follow the method that we did earlier. So 3 boys times 4 girls, there's no singles that's not a boy or a girl, hopefully, and then plus the groups that are allowed to move, So 3 factorial, 4 factorial, 2 factorial. And that is actually equal to 288 different possibilities, where 7 factorial was actually equal to 5,040 different possibilities. Question 3. In how many ways can they sit if only the girls sit as a group? So if I just go to the picture now, so there's 3 boys that don't sit as a group now, and then the girls. So all 3 boys could sit next to each other, or 1 could move to the end, or 2 can move to the end, or 3 can move to the end. Now I need to write the math to compensate for that. And that would then be the 4 girls factorial plus the 3 boys that is sitting on single seats, and then plus the 1 group for the girls that can move around. And that answer would then be 576. Question 4. In the group, there is a couple, but they had a huge fight. In how many ways can they sit so that this boy will not sit next to his soon-to-be ex-girlfriend? Okay, awkward. But how am I going to do the math for this? Now, many times in an exam especially, they will ask you, what is the chance of something not happening? Now, we saw there's 5,000 different ways that these people can sit. I'm not going to work out all the ways where they are not going to sit next to each other. I'm going to sit here forever. So when you get a not question, work out exactly what they're asking you not to do, and then just say all the options minus that little amount that could happen. So let's look at this. I need to now check what is the awkward chance that they might sit together. So I'm going to say it's 2 factorial because they will form a group, and then there are 5 singles next to it. So I can write this as 2 factorial, the 5 singles plus the couple that can move, and then I would just get that answer, and that would then be subtracted from the 5,040 to find the correct answer. So we can see that 1,440 of these cases would be where those 2 sit next to each other. That's very awkward if you're in a group and 2 people are fighting. So we don't want that to happen. So the answer in this case would be all the possibilities, so 7 factorial minus this answer, and then that would equal 3,600 different ways where they do not need to sit next to each other and ruin the movie for everyone. Question 5. What is the probability of the boys and girls alternating? Okay, so this is also a question that you can expect. So alternating, let's just draw the 7 seats. Okay, so alternating means that they're going to sit boy, girl, or girl, boy, girl, boy. Okay, so the top row worked out. There were 4 girls and 3 boys. But now, with the bottom one, I do not have another boy to put there, so 2 girls will have to sit next to each other. And in this question, they said that should not happen. They must alternate. So I'm not going to count this bottom one. Now I need to think how many girls can sit on the first chair. So there's 4. Then if 1 sits, there's 3. Then 2, then 1. And then with the boys, this would be 3 times 2 times 1. Okay, guys, now don't get confused with this question. This is the same as if I just wrote 4 factorial times 3 factorial. Because it's multiply, I can move things around and it would still give me the same answer. Okay, so that would be the answer to the question, 4 factorial times 3 factorial. And because it was probability, I need to divide it by 7 factorial. Please now try the practice video and see if this really makes sense.
If this video helped you, please like and subscribe.
Jmath.